Welcome to qnawire.
Here what we're going to have is essentially an inelastic collision. We have a 500 milligram basketball. This is going to be mass 1, which have velocity 1 that is going to be equal to 4.18 meters per second going to the west. So that means that it is going on the negative x-axis, minus I, at the top of its arc. At that point, it is struck by an arrow that has a mass equal to 58.4 grams, flying at B2 is going to be equal to 38.2 meters per second, 60 degrees north of west. So that means that we're going to have a negative x component and a positive y component. So B2 of x is going to be equal, if we draw this vector in a diagram on x and y, and we know that the angle is of 60 degrees, the arrow is going to be flying up because we have the positive value for the velocity over here on the y-axis. So the x component is going to be equal to cosine of 60 degrees times my velocity, which is 38.2 meters per second. Similarly, the velocity of 2 on y is going to be equal to 38.2 meters per second times the sine of 60 degrees. Each of them is going to give us 19.1 meters per second, and sine of 60 is going to be times 38.2 is going to give us 33.082 meters per second. Okay, so now with this information, we know that the velocity on y it's only going to have an x component. The same thing goes with the arrow, because since it is going to the west, the x component is going to be minus in the I direction. For the y component, we use the unit vector j. So what we're going to have, since we have an inelastic collision, we have that mass 1, velocity 1, plus mass 2, velocity 2, is going to be equal to the sum of the masses times the final velocity. So from here, we know that the final velocity is going to be equal to mass 1, b1, plus mass 2, b2, divided by the sum of the masses. But in this case, since we're going to have a two-dimensional motion, due to the arrow being at an angle, we need to do this for the x component and also for the y component. Plus mass 2, b2, y divided by mass 1 plus m2. So over here, we just need to substitute the values. The velocity on 1 on x is going to be minus 4.18 minus 4.18 meters per second times the mass, which is equal to 550 grams, plus mass 2, that was equal to 58.4 grams, times the velocity. In this case, it's also going to be negative 19.1 meters per second, divided by the sum of the masses, which is going to give us 608.4 grams. We're going to do exactly the same procedure with the final velocity on the y-axis, but now notice that the velocity 1 on y is going to be equal to 0. And the only one that is going to have a mass and velocity associated to the axis is going to be, in this case it would be 33.082. It's going to be the arrow, meters per second. And the velocity is going to be positive. And this we're going to divide it by 608.4 grams, which is going to be the total mass. This comes from adding up 550 with 58.4. So the final velocity on x and final velocity on y are going to be equal to minus 5.612 on the I direction, meters per second, and on y, it's going to be directly 58.4 times 33.082 divided by 608.4 grams. This is going to give us 3.175, 52, well, 524 on the y-axis, meters per second. And the final velocity as a vector is going to be equal to the square root of the sum of both of these components squared. This is going to give us 6.448 meters per second, which is approximately 6.45 meters per second. So with that, it would be all. Thank you very much and have a good one. Oh, just a comment here. This would be the magnitude of the final velocity, of course, meaning the speed.